Thank you for coming to this session on digital twins for plants. This is just a little bit of what the agenda would be. So I'm going to speak a little bit about digital twins. Vikas will talk about their application at Shell. And Kyle will be joining at Cheetah to talk about some of the trends and what ExxonMobil is doing. And then we'll have a panel discussion, and the technology provider for Shell, Brian, will join the panel discussion. All right. Okay. So I think when we start talking about digital twins, it's such a broad topic. We should talk a little bit about what we mean by digital twins. So the common definition is that first line: a digital representation of a physical thing that either exists or is about to exist. So in the design and build cycle, the asset doesn't quite exist yet, but we have digital twins to design and build an asset. And then after it goes into operate and maintain, then we have digital twins for an asset that exists. All right. Now, this has moved to the digital twin having a 3D model. And in that model, there are software objects. So you can think of an asset, a pump. You double click on that pump, and up comes a dialog box, which gives you more information about that particular asset. It could be links to engineering documentation, or it could be operating information for the operate and maintain cycle of the life of the asset. Now, there also needs to be analytics or process models in there to, in the case of design, in the design and build for the design of the product, and over an operate and maintain, we see things like predictive maintenance going on. So there are these analytics going on within the digital twin. And it's dynamic. So in the case of design and build, documentations are being changed, data is being changed about the design, and we want the most current information available to everybody who's involved in that project. And then when you go over to operate and maintain, we'll see more maybe reliability, maintenance, operating parameters of the asset coming into play. So we see this digital twin covering both both design and build, operate and maintain. And to go into that a little bit more detail in another slide, let me first talk about the main components of a digital twin. So you've got components that bring in data through multiple sources. So you have data connectors, and then that ties into some model. Nowadays, it's both physics-based and AI-based, but particularly as AI matures. Then we get into 3D visualization, and our recommendation is use data federation. You don't want to replicate the data or try to avoid that, because that creates data integrity and data quality issues. And then there are applications on top of that for the various functions, whether it be on the design and build side of the world or operate and maintain. Now, they're underlying this, there also needs to be some governance. Things like who can read data values, who can edit those data values, who can create brand new data values, for example, or change aspects of the model. There needs to be some governance underneath that. Right? And again, the digital twin is a virtual replica of a physical thing. Did I miss anything on there? No, I don't think so. All right. This one's a little bit more complicated, because you heard me talk about design and build and operate and maintain, and I feel a need to delve into that in a lot more detail. So in the center, the graphic, there on the left, the design and build circle really is referring to all the different types of business processes associated with design and build of a plant or an asset, an upgrade. Then on the other side, let me get this right. The right side, you have operate and maintain. There's a circle, then a whole set of business processes associated with asset performance management, for example, reliability, maintenance, engineering, maybe LIMS, environmental safety and health type applications, all right? And there is some overlap, and that's the continuous handover part of it. And the little thing on the bottom, you learn when you operate and maintain, and you plan and upgrade. So this kind of represents the life of a plant. You know, not many of us are in green fields. Most of us are in brown fields. And this represents the asset life cycle of a brownfield type plant where you design and build an upgrade, operate and maintain it, learn, and design and build the next upgrade type of thing. So on the left-hand side, I'll talk about the design and build type of digital twin and what aspects that has. So obviously there's some design capability. That could be pre-feed, feed, mechanical design, et cetera, within there. And you want all the contractors to have access to the same information. So a lot of this is read capability, but maybe they can add some notes. But one of the major issues in design and build, why projects go over budget, is because somebody has an old version of the document. They construct something based on that document, and then there needs to be a rework because it's out of date. And that causes, obviously, increased costs, but also delays the project and really impacts the key KPIs for a project, which is around on time, in budget, and on spec. All right? And then you can also optimize the construction sequence. So, you know, you have maybe several pieces of equipment that goes in the room. One is large, the other ones may be smaller. When I move that piece of equipment in the room, the larger piece of equipment, is there room for it? Which order do I need to put that equipment in there? And this is just a simplified example. But you can get a sense for how, because the digital twin has dimensional accuracy, so you can understand when to move in a particular asset, as an example, and optimize the construction sequence. There are cases where people have been able to reduce the length of the design and build project, get faster time to benefit, so that directly impacts revenue. And that becomes, I think, the key business benefit from a C-suite perspective of the project digital twin for design and build is revenue. Bring the project much more reliability on stream more quickly and getting the revenue more quickly. All right, let's go over to the other side, the performance digital twin for operate and maintain. Now we have a whole different set of business processes around asset performance management that get optimized. Reliability, maintenance, engineers to the process engineering and the smaller projects that may improve the reliability of a piece of equipment, for example, or its operating performance. Again, now the common engineering data and documentation occurs across those groups, across the reliability. You're going to get sick and tired of me saying this, I think. Reliability, maintenance, and engineering. You know, right now, those are often separate organizations with their separate documentation, data, their own data warehouses, and a lot of discontinuities occur because they're all different. This is an opportunity to get everybody on the same page with the same documentation, data, and usually conflicts diminish when people have access to the same information, and it just becomes easier to manage. Here, the analytics typically are associated with predictive maintenance to prevent unplanned downtime, which avoiding that unplanned downtime gets us to the key revenue. without unplanned downtime. Of course, obviously you can't make product if the equipment isn't running. So again, this brings us to revenue. Because you increase capacity, the overall production schedule becomes much more reliable, much more likely to deliver product on time from a customer perspective, have better customer relationships, and also increase revenue from that perspective. So again, the key benefit of this comes from revenue from a C-suite perspective. I'll get into the asset longevity later on as a benefit and why that can lead to higher stockholder value. The engineering productivity in general, people report to me that roughly 30% of engineering time is spent looking for documentation, looking for the most current version. And with a performance digital twin, giving everybody access to the same documentation, that should be dramatically reduced. So in closing, for this slide, project digital twins, keep in mind, they should be justified based on revenue. More reliability, more reliable project execution and delivery. And again, the performance digital twin, the executive benefit is revenue again with higher capacity. So what I'd like to show the next two slides, this slide and the next slide, is just a chance to visualize what we mean by these digital twins. So this first one is more around the design and build. And it looks like the software you would use to mechanical design the plant. And the digital twin just expands that to make it available to a lot broader audience involved in the design and build of the plant. And then in the case of operate and maintain, in this case, the background image, the 3D image, is created from a point cloud. And you can use photogrammetry or other means to get the as-built conditions and as-maintained conditions rather than a CAD drawing or the CAD system. And you can see that one of those tanks are kind of highlighted. Someone converted that to a software object. Double click on it, this dialog box comes up. And in this case of this dialog box, you see in the lower left, it looks like a P&ID drawing. And on the top of the dialog box is probably, looks like data coming out of a historian. So it's more operating data, right? So you can see some significant difference compared to the previous one about how this digital twin would work and what it would look like for the operate and maintain side of the world. Now, we're going to talk about this in a lot more detail in the next session that is led by Peter, my peer, Peter Reynolds. But I just want to talk a little bit of how this is transitioning to a next generation type digital twin. And it's called the Sustainable Asset Digital Twin. In this context, sustainable means that the digital twin is sustainable throughout the life cycle of the asset. Design and build, could have a 2, 3, maybe 4 year for a new plant, 4-year life cycle. For an upgrade, maybe 90 days type of thing. But here, sustainable is referred to well into operate and maintain, which could go on for many decades. That is what sustainable means here. We want, all too often I see digital twins that are made in the design and build cycle. They go through operate and maintain and they die. They slowly atrophy and go away. They don't get support because they are not built for the business process associated with asset performance management that is desperately needed in the operate and maintain side of the world. So this sustainable asset digital twin is kind of an initiative, a working group, how to get to a much more sustainable, longer life digital twin. So I'm going to talk about these 3 circles just a little bit. The experts are going to be in the next session, so this is more of an introduction. So we talk about visualization. Now when we talk to people about a particular asset, we refer to a tag, P103, pump number 103. And from a user interface and usability viewpoint, that isn't too friendly. It would be nicer if you had a 3D model, you can navigate to that asset and double click on it and get the information you need, rather than having to go to a table of tags and memorize tag names type of thing. So it's a 3D for planning. So in the design and build side of it, that could be planning around construction sequence. In the operate and maintain side of the world, that planning would become something like, as an example, you've got an urgent work order in a particular area. The maintenance player does a query and says, tell me all the work orders within, 50 or 100 feet of that asset. And maybe when that maintenance technician goes out there, they could do more than one thing during that trip. Your plants, particularly in the sites, they can be many miles in width and length. So having multiple things done by a technician when they go out there is a huge productivity improvement. And the collaboration, one can imagine a Zoom type meeting where the leader for a project is bringing up the 3D model and navigating to the asset that needs to be. So everybody is on the same page about what asset they're talking about, and everybody has situational awareness at the same time. If we go to the process models on the side, so on the engineering side, this is engineering simulation and operate, maintain. It may turn into a lot of predictive maintenance. Those models get maybe redeployed in a different way. And on the bottom, we have federated data and documentation. Again, we recommend federation rather than replication. And one could start to think about this in each one of these circles become replaceable. So on the design and build side, the process models may be around feed, for example, but as one goes to operate and maintain, it may make sense to unplug that and put in predictive maintenance type models, which may be a little different in nature. On the visualization side, we may see in design and build a visualization based on the CAD drawings, but as we go to operate and maintain, it may be, particularly for a brownfield, it may make sense to start using point clouds or photogrammetry type 3D models. And we want those changes to be able to occur on top of the same data platform without having to replace the data at all right? And, within each of these areas there, and between those areas, there should be some business process automation to automate, when an alert happens in one area or there's an issue in one area, the people who can do something about that alert are engaged and well-informed. All right? And again, there needs to be governance around it. Who can read, who can write, who can change the model, et cetera. Again, the next session, the experts are going to be there and be able to get into this a lot more detail. But this is at least my understanding of what we mean by a sustainable asset digital twin at this point in time. All right. Now, one aspect of a digital twin, we talk about digital twins a lot in terms of creating them, but how do we manage them and keep them at a high performance level? So this is borrowing from data science. It's called, in data science, they call it the confusion matrix. I'm not sure that's a good name for it in this space. But let me first just talk a little bit about what the top here. So in the actual world, you may have a positive in the sense that the process is working. There is the process is working well, and things are going. No, wait, I got that backwards. We got the positive really means that there is a positive problem. There is a problem, and negative means that things are working fine. And then you have your 3D model in a similar way may do a prediction that indicates that there's a problem, there should be an alert. And sometimes that prediction is, it doesn't identify a problem, all right? So obviously true positives are the best. When there is really a problem and the digital twin predicts that problem, that's what you want. You start pissing off the maintenance people, quite frankly, if you generate a positive and it's really not an issue, all right? So you want to try to avoid those false positives. So one thing to measure is the ratio of true positive over false positive, and over time, drive that down. Now, psychology studies say that, and this comes from reports in Psychology Today, that if you do something that's a problem for your spouse, you've got to do 20 things right before your spouse is okay with that problem and forgets the problem, all right? So we would recommend that when that ratio is above 5%, that the alerts go to engineering to help improve the model. When they are below 5%, they can go directly to your maintenance planner to schedule an inspection or whatever that maintenance planner deems to be appropriate for the problem identified, all right? And then around the negatives, meaning that there was a problem but the model didn't find it, typically what this means is that there's a failure mode that the model did not address. You know, you typically, when you write a predictive maintenance model, for example, you do it for a primary failure mode, but there may be other failure modes. And so when there is a unplanned downtime, you usually can identify that out of your EAM maintenance management application, and that should go to engineering for a review of the model for other failure modes, all right? I think that's all I wanted to say here. Okay, so let's get into benefits and justification. You know, this McKinsey report shocked me in that 98%, I'm mainly going to talk about the top part of it, 98% of projects are over budget. So we see EPCs adopting digital twins in terms of the case stories that I've been involved in around controlling the KPIs on time, on budget, and in spec. It's helping the EPC avoid penalties associated with being late or out of spec, right? And that obviously helps out with their margin. For the owner-operator, we see the key benefit being faster uptime, and faster completion so that they have higher revenue. And then on the operate and maintain side of it, this first list is the key metrics of the maintenance department. Now I'm going to mainly talk about these two. What I see as a key problem in financial justification of projects in the operate and maintain side of the world is they tend to be written by engineers who focus on costs, maintenance costs. And they tend to write the justification based on reduced maintenance time and fewer maintenance techs. And that almost always is a difficult justification. There isn't enough return and business benefit. And typically the maintenance technicians are not laid off. The maintenance manager finds other things to do for them to do. So when the finance department audits a project, you look really bad because you didn't save anything, all right? So I would recommend not going down this route, to instead focus on less unplanned downtime so you have higher revenue. That certainly affects the KPIs of the C-suite because it affects the P&L statement. And obviously that is how they're measured by Wall Street, their KPIs. And the other one is around asset longevity. If you keep the asset on the books longer, it's depreciated more. So the value of the assets in the balance sheet is lower, and that, from a Wall Street perspective, is a good thing. And the way that comes up is in ROA. So in the top, you're improving profit with more revenue, and on the bottom, you're reducing assets, the value of those assets, because they last longer and they're more fully depreciated, and you improve ROA. That gets C-suite attention because it improves stockholder value. That gets to one of the key ratios used by financial analysts to measure the value of the stock. Yeah. Okay, my last slide. This is more conceptual in nature, where we hope to get to in the not too distant future. I'll start off with unit digital twins. This here, I'm talking about a piece of equipment. And, in the discrete industries, it could be a robot, CNC machine. In the process industries, it could be maybe a pump or, a skid mount piece of equipment, as an example. Those suppliers of that kind of equipment traditionally focus on functionality. Speeds, feeds, in the case of the discrete industries, and other aspects in the case of the process industries. And the value of software, Tesla is kind of the poster child for this. The value of software is starting to exceed the functionality issue. It's starting to become the differentiator among OEMs and equipment. So I think in the not too distant future, an OEM who can deliver a good digital twin with their project is going to have a core competitive advantage and win in the market. And they will be driven to provide digital twins that can plug into a larger digital twin, a plant digital twin, that the owner or operator would be responsible for. And, it's popular to talk about metaverse, but I think that will play at some point in time. These plant digital twins will plug into a broader metaverse for an enterprise, an example.